we are doing the priority queue, and in the priority queue we have the node as a value and the priority. We were doing max heap where we were having only value, but now we have to do the priority queue. So when we let's see, two things we have to understand in the priority queue: how you will insert it and how will you remove it. Insertion is called the NQ, and deletion, removal, is called the DQ. So to insert it, what we do, we create a new node based on the value and priority, and we first push that new node in the value at the end. So let's repeat in short a few things. So how the priority queue works. So initially, let's say we have some items in the priority queue. So this has the, let's say, 100 priority, and this is, let's say, 50 and 60, and then here let's say 30 and 20, something like this. So when we want to insert a new node, we create this node with the value maybe, for example, is 40, and priority is something whatever we give the priority. So this priority is 40, for example, value is XYZ, whatever it is. So first thing is we need to put this 40 at the end of the array. So when we are creating the priority queue, this tree structure is in the form of the array. So like we have 100, and then 50, then we have 60, then we have 30 and 20. So first thing is we need to put this 40 at the end. So we put 40 at the end, and here it will be 40 here. So first we put the 40 in the end, and then we compare this 40 with the parent and check if the parent is greater, then we don't need to do anything, because parent has more priority 60 than this 40, so we don't need to do anything. But for example, if I'm adding 200, so first thing we need to add in the end of the array 200, and then we'll check whether 200 is comparable to 60. If 200 is greater than 60, then we swap. So 60 will come here and 200 will go here. So 200 will come here. Then we again compare this 200 with the parent, and 200 is greater than 100. So 200 will come here, 100 will come here. So this is how we insert the node. So first is always we put it at the end of the values. That's how we do in the priority queue. So what we do, we first push at the end of the array, then we loop it and find the parent of the current element which is added. And if parent's priority is greater, then we don't need to do anything because we are at the correct spot. But if parent's priority is smaller, then we replace the current element with the parent and the parent's element with the current. And we update the index to the parent index. And then we again go to the while loop and compare the parent with the grandparent, and then we go move on up and up and up. So this is how we insert in the priority queue. Priority queue is a very important topic. You should remember these steps also and the idea behind it. Now today we will do the DQ, that is the removal of the priority queue. Okay, after I do DQ, I will ask few questions on this priority queue. So try to pay attention on both insertion and removal. So we have to remove the element. So how to remove the element? Let's come to this figure again. So let's say if we have this as 100 priority, and then we have 50 and 60 priority, and then we have 30 and 20 priority here, and let's say here we have 40, and here maybe we can say 40, maybe 15. Sum of 15 is here. Okay, so this is my tree is there, priority queue is there, and if I draw element is 100, 50, 60, and we can travel parent or child using the formula which I explained in the max heap. 30, 20, 40, and 15. So we want to remove deletion. So in the deletion, what is the first step in the deletion? Deletion is we have to remove this part. Deletion means the top one will be removed. This has to be removed. In the priority queue, deletion will happen at the top level, that is this level. So the first step is I will put this 100 in some variable. Maybe I will say removed element. Removed. I can name anything. I'm just saying removed element. What is that removed element? It's 100. Okay. So first thing is we have to remove it from the top of the tree. That is the first element. That is this element. So what will be the code I have to write it? Can anyone tell me the code which I have to write it? Because I have to remove the top one. So what should I write here to take the top element in some variable? How will you know the top element? What is the code for it? I know it's 100, but how will you figure out? It can be 400 also, it can be 200 also. So what is the variable to extract this information? So we have everything in the values array. This whole thing is in the values array, and I want to get the 100. So what should I write down in removing? Okay. Okay, shift will not work. Because we don't want to empty this space. We just want this in some variable. Okay, we don't want to remove it now immediately. We just want this variable to be saved in this another variable. So right now we are not immediately removing it, but ultimately we have to remove it from the array. Okay, so splice is shift is almost gives the same result. So we don't want to delete this part kind of thing right now. We just want to remove it, and then we need to replace it with something, because we are not removing it, this part from the array. From the array, this 0 position will be there, but we are not deleting that position. Okay, first thing, I'll just put some one condition. If we don't have anything in the value, that means if the whole tree is empty, then we don't need to remove anything. So if I say if this dot value dot length is equal to 0, then we don't need to do anything. I will return false. Okay, now you tell me I will create a variable called as removed element, which will be removed is equal to what should I write? Which element will be removed? Which element from the values will be removed? 0. So we have to say this dot values dot 0. So this is the element which will be removed and which will be given to the user, that this is the element, you take it. And we are removing it from the priority queue. Removed element to the user. Okay. So this will be removed. So right now this will be 100 as in our example. Okay. So in this example it is 100. Okay, so we created this 100 in some variable because we want to remove it, this one. Ultimately, we have to return this removed element to the user. So aim is to send this information to the user when we return it. So let's do that part. So when we complete the DQ, we will return removed element. Okay, so this element will be returned. Okay, now next thing is next process is, this is the first number one. Second one idea is we have to take the last element and put it at the first 0 position here. Take last and put it here. Okay, that is the next one. So we have to remove this, put it at the 0 position. So what I will say here, constant end, this is the end element is equal to, now since we have to remove one, so we have to delete one element from this array. So now we will pop this out. We have to pop this out so that one element should be reduced from the overall array. So what I will do, this dot values dot pop. When I say pop means it will take from the end and reduce the size of the array. So this 15 will go away and it will be saved in the variable called as end element, and the whole array length will become shorter. Okay, so we put this 15 in the end element. Now we have to put this 15 at the top level. Next step is put the 15 at the top level. Once okay. Okay, so we took this end element and we pop this end element here, right? Okay. Let's see what is the next step now. Okay, here after this line, I will put some condition here later, but right now, let's move further. I have some checksum here, which I will put later. I will put to do add some checksum. That I will explain in some time when we are done. Okay, so what I did, I have to take this end element and put it at the 0th position. What is the 0th position? This one. So what should I write so that it should go into 0 position? So what should I write here? So that at 0 position my end element exists. Okay, what should I write here so that my 0th position should have this element? Value 0 equal to end element, right? There's no need to swap now. We have to just say, because first element is gone, so no swapping, only we have to say this dot values of 0 is equal to end element. Okay, so now after these 3 lines of the statement, how our image will look? Let me Let me copy this. So after 3 lines, this 15 is gone. This 100 is also gone. It comes outside here, and here we will get this 15 here. Is that clear till now? So we remove the top element, put it in some variable which will go out, and we took the last element, put it at the 0 position. Okay. Is that clear till now? Now we have this tree, new tree. Now what do you think? This tree is okay, or we need to modify this tree? Is this tree okay? Need to modify. Now why we need to modify? Why we need to modify this tree? What is the problem with this tree? And remember, this 15 is a priority. It has a value, maybe anything, X, Y, Z, patient name, or anything will be there. Why we need to modify the tree? What is the problem with this tree? Because 20, 30, 40 not in order. 20, 30, 40. This is not the right reason. We have to modify the tree not because of 20, 30, 40. What is the right reason to modify this tree? Yes, setting the priority. Right now, if you see 15 is at the top level, 15 is at top level with incorrect priority. In the top level, it should be having the highest priority. So if I have 15 at the top level, that means the priority is not right. We need to set the priority correctly. So let's go further to manipulate our tree. Okay. So now what I will say, manipulate the tree to set the highest priority at top. Okay, so what we have to do, first we have to take the index of this 15 because 15 is incorrect. Rest others were in place. We moved the 15 to the top. Now 15 is incorrect, but all other things are at correct spot. So what we have to do, we have to take the index of this 15 and we have to move it down somewhere. Okay, so I will say let index equal to 0 because top level is 0 and the value of top level is 15 in our case. Now what is the total length of the values? We will put the total length of the values. So I will say length equal to this dot values dot length. This length is taken so that we should not go out of the bound. We should only do our coding till we have the total values of length. And I will also put element which I have to move down, that is 15 number. I have to move down, though it is here end element is there, but this part can be in another function also. So we will separately take the value and put it in the element which we want to manipulate it. This dot values of 0. So we have to manipulate the top element that is at position number 0. So though it is end element, it is at the value 0, but we are putting in some extra variable for our calculation purpose. If we take that above 1 also, it's fine. But right now I want to put it in separate variable. Now we have to use the while loop to travel this 15 to down, maybe left side or right side. Okay. So we have to use the while loop. And while till we continue going down, we will use true. And we'll write our code here that move the 15 to appropriate position, because we don't know exactly how much 15 we have to move it down. That's the reason we are using while loop with the true, and it will go on doing while loop till we reach at the proper spot. Now we have to take the left child of this 15 and the right child of this 15 also, because we don't know 15 will go on the left side or right side. So we have to manipulate both the things. We need to calculate both the things, left side and the right side. So let's go and write the left child index. Now to calculate the left child index, we have the formula 2n plus 1. That is 2 into index plus 1. So this I have already told you long back. What is the formula for the left child? That is 2 into index. Current element is index 0. So we multiply 2 into 0, that is 2, that is 0, plus 1. That is the position number 1. That is this one. This is the position number 1. So left child is at 2 into index plus 1. And right child index is 2 into index plus 2. So 2 into 0, this is the 0 element. 2 into 0 is 0. 0 plus 2 is this one. So this one is the right child. So this is the formula for the left child. This is the formula for the right child. To access the left child and the right child, you by heart this formula for the left child and the right child and the parent formula. This is the parent formula is n minus 1 upon 2. Math.float n, that is index minus 1 upon 2. This is the formula for the. So remember these two formulas, three formula, one for parent, one for left side, one for the right child. So I will write down here. Parent is math.float. It is math.float n minus 1 upon 2. So it's called n minus 1 divided by 2, and we have to float it. And for the child, it is 2 into n plus 1 and 2 into n plus 2. So remember this formula by heart. Okay. I will put in the chat, create Telegram group. Okay. So we are getting the left child index and the right child index. What is the left child index in our case, in our example? It is 1 with the value of 50. 1 with the value of 50. And this is 2 with value of 60. Initially, we don't know 50 is there or not there, 60 is value is there or not there. So we will put current value as null for now. So I'll say left child is null initially till we figure out the value. This is something we're looking at the graph, I'm putting the value, but with the coding we need to figure out whether the value is there or not. Sometimes you don't have left child. Sometimes you don't have right child. I'll say right child is equal to null. Also, I'll create one variable called as swap, whether swap is needed or not. And if swap is needed, I will update this swap to some value. Right now, I'll make swap as null. This is to confirm if we need swap. Based on some if condition, we will change the swap to true or some value. And swap is there, then we will swap it. Now, first thing, we are here at 0 level and we have the left child 1, right child 2. So this is the 0 level. So let's delete this. So 0 level we have 15. This is 0 level. This is 1. This is 2. If we were at 1, it would have the child of 1 into 2 plus 1, maybe 3 and 4. And if I would have been 2, the child would have been 5 and 6. Okay. So this is how we proceed down. Right now we are at the 1 and 2. Child is 1 and 2. Now first thing is we have to go through left side and then we have to go to right side. Both we have to calculate where 15 should go, whether on the left side or on the right side. Okay, let's try to go now to the left or right side. First I have to check whether left child index is valid or not. Maybe left child index is sometimes 6 or right side index is 6 and we don't have 6 in this whole array. So we have to check whether the index which I have calculated exists in our world or not. So how to calculate if index is there? We will say left child index should be less than length. So it should be less than this total value dot length. And if it is greater than the total value dot length, that means it is out of the bound and we don't have the left child. We don't need the left child for this array. So it should be less than the length. Then only we will do some calculation on the left side. Same thing we have to do with the right child. If right child index is less than length. And if both are not less than length, that means they are out of bound. We don't need to worry about them. So both should be less than the length. Now, since left child is less than the length, that means there is some left child index. So we have to calculate the value. So I will say left child is equal to, so what will be the value of the left child? This dot values left child index. So whatever index we have for the left child, we will take the left child value. In our case, value of the left child will be 50 because left child index is 1 and the values of 1 is this 50. So in our case, left child is 50. Same thing here I will do on the right side. Right child is equal to this dot values. If we have right child index greater than the length, that means it exists. So we have to find the value. In our case, what is the value of the right child? It is 60. Now let's go back to again left child. We have to check whether this left child is greater than this one or not. If left child is greater than this one, then that means swap is needed. We don't know left side or right side, but at least swap is needed. So what I will do here, if left child dot priority, we always take the priority. If left child priority is greater than, so if left child priority, that is 50, is greater than 15, then we need the swap. So I'll say if left child priority is greater than this 15, 15 means we are using element. So we have to check with element dot priority. So if I'm saying if left child priority is greater, that means left child can move to the top. But we don't know left child will go or right child. So we will just say swap is needed. So what I will do, I will say swap equal to left child index. So what I'm doing, I'm putting swap as a left child index. I'm not swapping it, you check here, because I'm not swapping it because we don't know whether it should be swapped with the left child or the right child. So we only know that if left child priority is greater, swap should occur between the element and left child or the right child. So we'll just make the swap as a left child index. We will only know whether it will be swapped with the right child or the left child after we done the calculation with the right child. So we already did the calculation with the left child and we made the swap equal to true. And what true means? We put the left child index. Okay, because swap will happen with the left child if right child is not valid. So we have to either swap with the left child or with the right child. So with this statement, we know that it should at least swap with left child if right child doesn't qualify. And if right child qualify, then we will swap it with the right child. Okay, so now in this case, swap has become true because left side 50 is greater than 15. So at least we have to swap 15 with the 50. So swap has become true. Swap has become 1 in this case because left child index is 1. Now we'll go to the right side and see whether it should be swapped with the right side or the left side. So here I will say let's say if this condition is false, then swap would be still null. Okay. So we have to take two cases. If left side is not the valid or swap is not there, then we will only concentrate on the right side. But if swap is there, then we have to consider left side and the right side. So I will ask question here. If we don't have swap, okay, if we don't have swap and what should I put here so that I will swap with the right child? What should be the criteria here? Swap is not there. That means this condition doesn't exist. That means left child is small or something is there. There's problem with the left side and we are not going to left side. If we are not going to the left side, that means swap is not there. Or we can say if swap is equal to null, because swap will be null. If swap equal to, or let's make no swap also in this case, it is not a problem. If swap is not there, then what should I put here so that I will make the swap equal to right child index. So here I have to put something so that I know that right child is a valid child for the swapping. Can anyone tell me what should I put it here? That means if swap has not happened, then what should I check with the right side so that I know that this element's priority, this element should be swapped with the right child. Yes, it's correct. Both has written correctly, Sonu Singh and Kate. So and we will check right child dot priority is greater than element dot priority. Okay, so if left side is, let's say, less than the element, that means we are not going in left side. That means swap is null. Then we check the right child's priority, and if right child priority is greater than the element priority, then we swap with the right child. But what if I will put here only one more condition? What if or what if swap has occurred? That means swap has some value and swap has occurred. That means swap has some value. That is, it has got this value 1 number. Now what should I check so that I should make swap as a right child? Previously I make the swap as a left child, but what should I put here so that I should swap with the right child, not the left child? So what can be the criteria here? So the only way the criteria is whoever is greater as the highest priority, that should go up. So if left child is 50, right child is 60, then right child should go up because right child has 60 priority, so it has more priority, so it should go up. So now we have to compare with the left side and the right side because swap has occurred. That means there is something in the left child which is valid swap. But if I check another condition with the right side and the left side, then I have to think that it should be solved with the right side, not the left side. So what should be another condition I should put here now so that I will say that, okay, right side should be solved, not the left side. So now what will be the condition here? Correct. Kate is correct. Now the comparison will become between the left side and the right side. Here the comparison was with the element. Here also comparison was with the element. Now since swap has occurred, that means left child is valid candidate. So here we will compare with the left side and the right side. So how to compare with the left side and the right side? I will say if right child dot priority is greater than left child dot priority. So that means if right child's priority is greater, then we will swap with the right side. We will not swap with the left side. So in this case, we will also say swap equal to right child index. And in our case, this is the example that right side is greater than the left side. So we have to swap with this 60 number, not the 50 number. So we will say swap equal to 2. Swap will become 2. In our case, swap will become 2. And this is the valid case in our example. We are using this one. Now, after this if condition, we have to check if swap is there or not. If no swap is there, that means we have not gone into this part also. That means swap is not needed, and we should come out of the loop and we return the whatever we have to return it. Because we will only swap if swap is true with some value. But if we have not reached this point, that means everything is in correct spot. We don't need to do anything. We have to come out of this while loop. And to come out of the while loop, we will use a break statement. So if swap is not there, that means this is not valid. Come out of the loop. We are at correct spot. Don't need to do anything. But if swap is there with the right or left, then we need to the swap. Swap of what we have to do? Swap of this with this. We have to swap these two. Okay, so how to do the swap of these two? Let's see it. So I will say this dot values dot index. Index is the 0 number, which is the current element 15 number is existing. Here I will put the child, right side or the left side. And how will I know right side or left side? By the value of the swap. So I will say this dot values of swap. Because swap can be right side also or it can be left side also. So the current index, the 15 number will be replaced with the swap. Swap is what? 2 number. So these two will be 50 number. This 60 will go to here. 60 will go here. With this line of statement, at index that is 0 spot, we will move 60 number because swap is right child, that is 2 number with the 60 value. Then we will say this dot values and with the SOP. What is the SOP? SOP is the 2 number and 2 number has to be replaced with the 50 number. This 2 number has to be replaced with the 50 number. So here 15 should come. 2 number is I already put swap, but I have to put the 15 number here. And 15 number is nothing but the element. This 15 is the element which will go here. So 15 will go here with this line. Add 2 number, 2 spot, we will move 15. And since we have moved it 15 here, now index will point to this number, not the 0 number which previously it was doing. So here I will say index is equal to SOP. SOP, that is the 2 number. So now index will be 2. Now again we have to calculate this index, whether this 15 will go more down or not. Okay, it should go more down because we have already 40 which is bigger than the 15. So after we reach here, index is here. Now we will go while loop again, follow the same procedure and move it down to here. Okay, so after this line, we will go through everything again. That is, what is the left child of this one? Left child of this is this one. So 2 into, what is this? 2 into 2 plus 1. 2 into 2, that is 4. 4 plus 1, that is 5. That is this 40 number. Left child is 40 number. Right child, 2 into 2, 4. 4 plus 2, 6. 6 is not there in the array. So we will not go to 6 number. And then we will check left side because right side is not there. We will make the SOP as the left child. And then SOP is there. We will SOP this 50 number with the 40 number. And we will SOP 40 number. And since after that there will be no left side, no right side. So SOP will be not there and we will break it. So ultimately we will send the removed element back. Okay, so that's how we are going to do it here. Okay, so this is something removal part. There is some problem here in this line statement which we will see in a bit. Let's try to do this and see how it works. Okay, so that's how we will be doing in a minute. Okay, so let me add all this one. Okay, what was there initially? It was, let's add the priority properly first. So gunshot wound, I will put 100, then 50 and 60. I have to put 50 and 60. Maybe I don't know which complaint will be 50 and 60. We'll put some complaint. C1 50. C2 60. Then we have 30 and 20. C3 30. C4 40. Okay, then we have 20. Okay. Then we will add this 40. 3 pi 40. Then we will put 15 in the end. C6. Okay, so let's try to run this and then we will do DQ. And in the DQ, we will get one issue which we have to fix it here. Okay, let's run this one. Okay, so we have node. First is 100, 50, 60, 30, 20, 40, 15. This is the same thing what we have here. Okay, now we will remove the top one. So how to remove? I will say pq.dq. Okay, once I say pq.dq, you will see 100 is removed. Okay, and then if I run this again, so now we have 6. 100 is removed, 60 is sent to the top. Let's do again. So we removed 60. Let's do the values. So now 50 is at the top. Let's do this again. Now 50 is removed. Now we have 40 at the top. Okay, now let's do, so now we have only one node, that is 15 at the top. Now I will try to remove this 15 and see what happens. So it's saying 50 removed, but still I have one node here 15. So though I'm removing it, but still it's being added again at the top level, this one. So though I removed it, but again I'm getting it back. So the problem happens when we have the one element and we try to remove it, but then we again try to add it. So let's see in the code what is the problem. So what happens if we have only one element? We have one element, so that element goes into the remove element, and then what we do? We assign that element also to the end element, and we again put this end element at the 0 position. Though it is removed here, it is added being here. So this is the problem. So we are removing it here, but we are adding it again here. So it's going into the loop. It's not never ending. So here we will put something. So here what I will do, if we have only one element, and then if we have removed it, that means the values of length become 0. And here I will put, if this dot value dot length is 0, that means there is only the one element which is being removed. So if it is 0, then I will return removed element. I will not add it back here. This part will not come. This part is not needed. So if after we remove, that is after this pop, we don't get anything, that means we have to just return the removed element. We don't need to go further because it was one element, it was removed, and it is to be removed out to the outside world. So let's run this now again. I will add only one now to show you that how the one works. Okay, now pq.values. So now we have the one element, that is 100. Let's remove it. Okay, so this is removed. Now again, if I check values, it is empty. Now we didn't get the loop of again and again getting it. Okay, so that's all for today for the priority queue. So now I'll give you time to write it down. Okay, I will scroll down once you are done with this one. It's better you write it down because you have to remember this everything. You have to do 10 times this whole function so that you can remember it. So at least write down one time now and 10 times again afterwards when you do practice. So let me know once you are done. I will scroll it down.